Welcome back everyone. Before we are going to actually see that what the processor is doing and making everything understandable in the way that we will never going to forget the experience of the microprocessor and this all kind of the boring stuff from it and removing that all kind of the information and become the subject, become the processor yourself. Okay, before that, let's just revise few things and have few of the points in our mind so that we will not going to get confused up from one topic to another and then we are going to see everything quite clearly. For that one, I need my eraser first. So I'm going to erase so many things from here and then I'm going to take you on a journey, the entire journey where we are going to learn something which we have not learned up to this point. Well, what could it be? That is the key aspect. Why 8086 is so popular and what are the few of the things? Well, I'm removing most of the data which is unrequired here and we don't need that one. So I'm removing that all kind of things. And now we have much space, I think so. So we can begin this thing right now. Okay, so as we know that this is our execution unit and this is our BIU for sure. This is BIU. So we have basically the partition of the 2 points. Okay, so what is actually happening? So first thing that I want you to be notice is that we are having the operand here. So what is the operand? Operand can perform the operations like plus, minus, multiply, divide, um, and, or, not, and these all the kind of things that we are having. So every kind of the operation, every kind of circuit is there present in the operations. And what is the flag? Well, that's my favorite one. So what is the flag? Well, if something is processing right now, the flag is up. When something is not processing, the flag is down, means nothing. Okay, it's not the zero, it's about the nothing. No, this is not the flag. Okay, so when any process is going on, the flag becomes zero, and when the process is has completed, when the process gets completed, it is 1. 1 means it's ready to fetch again the next instruction and execute the things up. So this is the role of the flag, and surely it has to talk two-way with the entire bus, and this is why it is having the direct connections. And obviously for the operands we require the numbers like a and b, we need to add, or let's say 3 and 4, 3 and 4, so something is going to add it. So if it is directly a number or it is direct information like I just wrote a and b, it will going to go all the way to the direct pipe. But if it is not, it has to get operated, flagged, and then go to the pipe. So ultimately the pipe is the thing that we should care about. That's the whole idea of it. Okay, so we have gone through the particulars and the details of the thing. Just one more last detail that I would like to give you a glimpse about, and then we are actually going to become the processor. Trust me, you will enjoy the journey. Okay, so what the next thing is? Well, we have talked about this fetching area. This will going to fetch 6-bit. Well, I might have said that this is byte, so let me correct it here. Everything that I said byte is actually bit. Okay, there is just a difference of the numbers, and I am very much habitual of the byte. Maybe I love the byte, so everything is bit. That's it, nothing else. So 6-bit, like it could be 0, 1, and this is particularly about the instructions. So it is pre-fetched instruction, not even the fetched, it is pre-fetched instruction. Like the example of the clinic, the patients outside are waiting here. Okay, so do you think that processor our processor is actually fetching the data of one bit at a time? Hmm, this is a good question. Oh. Yes, I think you said that in the clinic. Let's open a clinic. So, in the clinic, there was a doctor. Well, recite the story with me again. So, there was a doctor, and the patients are coming in the row, and one patient is going inside, and then again one person joins him, and this kind of things is happening. So, yes, I think that there is only one person at a time. Wait for a while, my dear friend. This cannot be the only scenario we are having. What if we have two doctors? Now, two patients can come together, right? Yes, and two instructions will going to be fetched together. This is the meaning of being 16-bit microprocessor 8086. In the 8085, one at a time. But in the 8086, it is not wasting the execution cycle like 65432 6 5 4 3 2 1. So what is actually the case when this one get empty, and so processor is not going to fill it up again. When this one is also going to empty, then only the processor will going to fill it up, means after 2 bit it will going to fill it up. This is the whole idea of it. When these two things get empty, only then the processor will going to fill it up, because this is the meaning of the 16 byte. Actually it's byte. Let me correct it. I said it right. Byte. I don't know why I confused it. So that's a byte. Okay, correction, that's the byte. 2 byte of data is getting fetched. Okay, what we mean with it, let me clarify this. When the processor is having when the processor actually sees that this is getting empty, it will not going to refill it. When it looks that two places or two things are getting empty, or 2 bytes are getting emptied, then only the processor is going to fill it up. This is the idea of two pipeline, or the whole concept of it. I hope you got my point here, because in the 16-bit, well, if you look at the hexadecimal point of view, so we have 8-8 distribution. So first 8 is the first stack, second 8 is the second stack. Like this is the 1 and this is the 2 that we were talking about here. When this both go out for the execution already and the queue shifted, means the first one is getting empty. Let me write it correctly so that we will not get confused out, and we can understand this concept quite clearly, I think. So it is 3 4 5 6. Now when these two are empty, the processor is going to fetch the data again, and then the 7 8 will going to come. These will going to come together, and not this is the scenario. This is not scenario that we are having here. Like we are having 2 3 4 5 6. This is empty. Processor is not going to fetch the data. Here processor is going to fetch the data. In case B, it is going to fetch the data, not in the case A. Why? Because it is 16-bit processor. That's the whole concept. So it is 8-bit and 8-bit. That's why we require this whole thing. And why to waste one cycle? When you see that two people gone away, then only you will send the two people in the queue. You have to queue two people at a time, not one. So when you will queue two people, when two people will go out, that's it. But sometimes in the real life and obviously in the processor, one person might come out faster and another take some time. Like there are the breaks, they take time. So you will not disturb the queue. You will not make this person stand in the row. You will make them stand together, not alone. This is the whole concept. I hope I've made my point clear, but if it getting confusing a little bit, because I feel like it sometimes get confusing, I try to explain my best possible way, but I will add that to the note section. Rest of that we have learned all the things. And just one more thing that I would like to address here is this ALU, arithmetic logic unit, that we are denoting with a sigma, is actually about the physical address. It is converting everything into the physical address. What is the physical address? Segment address multiply 10 plus offset address, right? So this is converting those things. So this is about the ALU, and here the ALU is actually having the operations to deal with: plus, minus, multiply, divide, and so on. Where the operations are happening? In the operands. What are the operands? Operands are a plus b. If you are having a plus b, a and b are the operands. What is plus minus? That's the work of the ALU. Well, I hope you have got my point very much clearly. So a and b are the operands, and plus minus multiply divide kind of the things is arithmetic logic unit. And what this ALU is doing on the BIU, it is actually converting the codes into the physical address so that it can be fetched from the memory. Well, with whole story together, now we are ready to learn the summary of the microprocessor. So till this point, whatever you have learned, just don't worry. Now we are going to see everything in the real and for the whole execution thing. I'm presenting you to the diagram, so just go on with my words. I'm not writing anything right now. Now you are going to become the processor. So whatever even I have left it, you are going to learn it quite clearly with a great understanding. Okay, let's begin. So this is the execution of the whole 8086 architecture. Let's go with it. All the instructions are stored in memory on the top, bottom left, actually top left. All instructions are stored in memory, and hence to fetch any instruction, first task is to obtain the physical address of the instruction to be fetched. We need a physical address that we are getting. Hence, this is the task that bus interface and segment registers are doing. Suppose the code segment has the segment address and the instruction pointer has some offset address. Then the physical address must be calculated by the sigma, by the ALU, arithmetic logic unit. It is going to convert the thing into the physical address. It is going to apply the formula, that is segment multiply 10 plus offset address. Then only we have the physical address. Okay, let's go with the point number 2. After the address calculation, instruction is fetched from memory and it passes through data bus as shown in the figure. You can see that quite clearly. And according to the size of the instruction prefetched queue fills up. Well, for example, you can have a move ax comma bx. Well, they both have 1 byte instruction, so you can take it like that one. Well, I'm going to discuss a bit about the assembly language, but not for now. Let's not just get confused. Let's proceed with the third point now. When our instruction is ready for the execution according to the first in first out protocol, which is queue basically, property of the queue instruction comes. Here the instruction decoding takes place. Interesting, right? The decoding control system generates an opcode, like I told you. Like if you want A, so we are going to have some kind of the opcode for it. Like A cannot be written directly into A. It must be like 0011. Like the white color is hash FFFF. That kind of thing. That is what we want here. Okay, so Microprocessor unit, which is operation is actually to be performed in this case, and then we are on the general purpose register, which is also called as a special purpose register. Why they are called special? Because you can use it, you as a programmer can use it. Well, hence after all these things, microprocessor fetches the data from general purpose register, and according to the instructions, like you are using the multiplication, addition, subtraction, division, it all going to fetch and put the ALU's input. It will going to be ALU's input because ALU actually knows that I have to add, subtract, multiply, divide, or whatever. The circuit is inside the ALU, Arithmetic Logic Unit. It has to multiply, divide, and all that kind of things. Now, according to the arithmetic, flag register gets activated and it has to change the value dynamically. Well, I'm focusing on the word dynamically because when the operation is completed, flag has to switch again to start the new process. That's the flag which is deciding everything. Like in the trains, when a new train has to go, you have to flag it, then it will go. That kind of the thing. Okay, let's proceed to the next step. While instruction was decoding and executing from before step, the algorithm the bus interface unit does not remain empty or idle. It is continuously fetches an instruction from memory and put it in a prefetched queue and gets ready for execution in the first in first out or queue, and whenever the time arrives for the execution it can send it directly inside. Like the example of our clinic, the person instruction pointer was there who is actually queuing the people and not making the doctor idle or just sitting around and no work is there. No, we are not going to left that kind of the case. We are going to make it continuous to make ourselves efficient, as much as efficient as we want. So finally, we are having 8085 is not having the pipeline structure, but we are having the pipeline structure, and this is the advantage of getting the pipeline structure, and that's how we use it. We use the partitioning, prefetching, all fetching of the data is happening. The bus unit is not remaining empty while the execution is happening. Processor knows that there is processing already happening, already done by the execution unit. So what it has to do, it is actually going to queue more people for the diagnosis. Like the clinic example, more people are standing in the queue to getting diagnosed, but there is a limitation of how many people can come at a time. These are the 6. These are on the right side, as you can see in the BIU 6 pre-fast queue. Now, when 2 of the people are gone inside for the diagnosis in the clinic, or in our case the execution, 2 more will going to be fetched, so that pre-fetched queue never remain empty and the execution can go on and on and on, and this all the thing happening at light fast. That's how the entire working of 8086 can be imagined. I hope you have understood the entire idea of the 8086 architecture. If you have any doubt about any kind of the segment or any kind of thing, you can just go on the previous, or you can just repeat this video, or you can just look at my notes that I'm uploading with this, and you can just have a look at that and you will know that, oha, that's what we are talking about. So this is the real life execution, and with this we have completed successfully the 8086 architecture, and I would like to congratulate you because it was a very tremendous job even to teach and even to learn in the very first glimpse. If you have learned most of it, well, that's fantastic, because this is how the microprocessor is actually working right now inside your phone, your iPhone, your smartphone, Android phone, whichever you are using, or in your laptop or PC, or whichever device you are watching me right now. It's working right now. Microprocessor is working right now, doing everything that you can imagine inside your machine. This is the power of the microprocessor. We are able to communicate, we are able to process the data, not the storage, because everyone's storage is different. Mine is 2 terabyte, your might be 5 terabyte someday, and they are maybe GBs. When we are using the phone, we don't prefer this much memory, maybe 4, 8, 10, 20, 80 GB, that kind of things that we are having. So we can have the variations, but still one thing don't change, which is very exciting, right? That is our processor. Processor is working the same thing. So the entire story can be summarized as, when anyone asks you that what a processor actually do, no matter which processor we are talking about, you can explain it in the three simple words: fetch the data, decodes the data, and then execute the data. That's the processor. That's what it's doing. No matter which processor we are talking about, this is what the processor is doing. I hope you have really enjoyed this 8086 journey architecture, and I hope that it will going to help you a lot. With all that said, if you have any doubts, you can always put it in question and discussion section. We are going to discuss extensively there if you have any kind of the doubt. And with all that said, that's it for right now. See you with the next update whenever I am going to update this course. Very much soon, actually. I've decided so many things, so I'm going to update this course again. Till that time, take care, God bless, keep smiling, keep learning, and see you in the next one.